Okay, we are back in the 900 science per minute factory, where we have finished off the flying robot frames. And let's see what's next. Looks like let's mark these as done when I've got them done. We did RCUs, we did low density structures, we did flying robot frames. So next up is processing units. 1086 processing units per minute. And I'm going to make a separate factory on the spreadsheet for this to allow me to do some juggling of numbers and do some things on site that the matrix doesn't let me do in the main factory. 1086. So it has been my habit in larger bases to make the red and green chips on site rather than do a simple little blue factory with 24 machines and import all of this crap, which is, it's not a lot, but it means that I have a larger red factory and a larger green factory, and all they're doing is shipping stuff to here. And if I can make it on site, I'm going to. So let's see, advanced circuits and electronic circuits and copper cable. So what does this come out to? Looking at these really quick, it looks very much like they're approximately 1 to 1 to 1 to 1. They're not exactly that, but they're pretty close. And that's what I like to build. Let's go over here where it's interesting. If I were doing this totally unbeaconed, oh, the robots are going to want to build that stuff up there. I might almost do, just line these machines up. Whoops. He goes there, and this guy is copper. So this is an order that provides for direct insertion of the highest volumes. So red and green go directly to blue, copper goes directly to green. We also need copper and green to go to red. So the other thing is this tight. I have previously tried to do this. I know you can't do this, not even with using express mini loaders to loop things around. It just, you end up having to do all sorts of weird stuff. And what I really want to do is make 24 copies of this. So probably 12 and 12. And I'm going to want to pack them vertically, which means that my beacons are going to go between them, which means we need to make space for beacons. Like that. And these are going to have, oops, like that. Put them in the right place. So there's our spacing. This is going to have to come in left or right because we're gonna pack these vertically, very densely. So the next thing is, how do these group up? And what I notice is that hold on. Items per minute. So 1086 items per minute would require this many belts. So with copper requiring 5.6 belts. I almost want to split it into 6 copies. And this is very wide, so what I'll do is I will put this and I will mirror it, and I'll have 3 sections. So I'm going to build one thing that is 1/6 of this. So we reduce this to 1/6. 1086 divided by 6. Clear. 1086 divided by 6 equals 181. So 181 times 6. Yeah, that actually happens to be very nice. So we need really to plan out for 181. So when I build this, I'm going to want to tile it 3 times and then flip the entire array, so I'll have a total of 6. And I'm going to flip it because there's going to be a lot of stuff coming in from one side or the other. I'm hoping I can bring things down for these guys and have that be common. It's the copper going here and the iron going here that we require a lot of. Okay, so at 1/6, now we see we need 4 of these, and I'm going to do 4 of those and 4 of those for direct insertion. But on the right, we've got this guy who also requires these. So if we have to turn off matrix. So he would need the equivalent of 4/10 of a machine of green circuits coming over and 8/10 of a machine of copper cable. Well, half of that is for here. So 0.4 machines of copper cable going into the 0.4 machines electronic circuit coupled with 0.4 machines. So we need an extra machine of copper, an extra machine of green chips to feed it to the right for this group of 4. Now outside the group of 4, we could do, 2 to 3, 3 to 4, whatever. I'm going to do these 1 to 1, which means we end up with 5 of these machines. 2, 3, oops. 3, 4, and an extra one of this. Actually, no, let's put the extra one at the bottom. So if I can bring these across on the 4, and on the last line we look a lot the same, but off to the right here we'll take the green and some of the coils and fold them back up here. Let's see what that looks like. But we are going to need at least this much in the way of so there's that. The other challenge here is going to be getting our power. See, one in the middle here cannot hit all of what we need. I could put it at this level and do something fancy down here. We're going to have a gap between these. I'm not sure how big that's going to be. I'm hoping to limit it. So what if we put it here? Let's give ourselves some power here. Yeah. Okay, robots, you go ahead and build those. That's going to be too many stations, but yeah. it's easier to trim it than to add more. Okay. And now we bring some power down, just like that. This may be tighter than I need. Maybe I can get away with that. Let's see if I can route that. So we need a belt coming in here, and I'm just going to send it right in like that. And the same thing for the iron. We'll work out the routing of those later. So I don't want to be trying to go horizontally through the middle of power. And I would like to cluster them up. So what if I do this? Okay. Boom, and boom. So that has my forwarding there. My forwarding here is going to look a lot the same. My forwarding here is going to look a lot the same. You gotta trust me on the piping here. I have a plan. Although, you know what? I'm going to move the power up a little bit, and I'm going to switch these around so that, well, that would make it so that, well, I'll show you. This is what you end up having to do. We need those coming out, and we need those like that. So the only alternative for routing is that. I can either have two of those, or I can do like this. That's not too bad. Now what does this give us? This gives us green and red coming in here, and sulfuric acid. So just by doing this just as such so far, we're now satisfied for our blue chips. Our green chips are going to need the copper coils and the iron, and if we've got iron coming in the left, we're satisfied, and copper is all set. So now I need to set up how we're getting this copper into the green and alongside it so that we can use it for something else. I think I'll move that up one. And now we've got one of these, and I'm going to have one extra pulling that out. These two are going to have to come together like that, and they will provide the bulk of the input for this guy. This also needs plastic. Well, that's going to be hard to deal with right there. I can't move these up and down by one because we're constrained here. So the most I could do would be to permute this. And that still wouldn't help. I can't move out here or I won't be able to make power connection. Oh, if I went there and there. Ah. I'm not sure if this distance is right. We'll adjust that when we put the next side down. So with this way, we now have, let's see, input into the copper coils. Hold on, is this going to be stack inserters? This requires 0.3 of a stack inserter. Okay, we're good. And this guy also requires, oh, he requires more than one inserter worth here, but these mini loaders are much faster. But 0.3 there. Okay, so we would not want to try to do a stack inserter on this line. Mini loaders are very nice. There we go. So his inputs are satisfied, his inputs are satisfied, his are satisfied, so now we go back and check here. I can bring plastic down on the left. Just like that. And the other thing is, it's not clear how far this needs to stretch. What is my maximum stretch? It's to here. And this maximum stretch, oh, what a coincidence. Isn't that right? That's nice. That just works out perfectly. So now we have plastic on the left, and this is going to continue down because our total plastic for the array is going to be less than a belt. So he can tile. This will go up and stop. Like that. Now let me rough this out. This, in terms of stack inserters, everybody is low. So we're good. And in terms of express belts, everybody is really low. So this wraparound half belt is not going to be moving very fast. This is good because we're feeding it from the one machine. Now, according to Max Rate Calculator, if we were running all of our green and red machines at maximum, we would be short by a machine, but we're not. Notice we've got 1.6 extra green chip machines and 0.5 extra. So some of these machines will be running less than full capacity, which means we could probably get rid of some speed beacons. But that's okay. That's perfectly all right. And now we need to bring our copper and iron inputs over from the left. Yeah. And these don't need to tile anywhere, they're just here. Just like that. And I think my total distance here is going to be 6 machines worth of distance, which may in fact exactly match the coverage of, yes, it exactly matches the coverage of the substation. So there's our second set of stuff. And the one thing I didn't do is I didn't arrange for any outputs. And this is going to be impossible. Okay, so the way these are set up, I have no way of extracting the output from them. Which means basically I need to move the power up one, which means swizzling a whole bunch of things here. But now that I know, I can dust all of this stuff in the middle, work out the new power setup. And yes, I do think this is going to hit all of my belts and inserters and such. So in the middle didn't work. We're going to try here. I wonder if I put this here, that will match up with the mirror to the right. I wonder if I can stretch it that far. Well, if I'm going to do that, I might be able to put it back at my original location. And see, that keeps the power away from the blue chip area, which was what turned out to be the challenge. Okay, so there. So first thing is peel off all of this stuff so I don't want to be biased by stuff like that. So we're back to this again. Yeah, I think I am going to go the other way. Move these up to here. Now, there may even be some more extended. I might be able to roll these up and down by quite a bit. Oh, yes, let's do that. I may be able to roll them up and down to the point where they are no longer in the way of anything. So there's my total grid. So if I put it there, it's basically out of the way. Put it there, that's even better out of the way. And we know that the stuff at the bottom edge is going to be good for that. There. So what I wanted to do here was use that construct. It simplifies how they tile. The next one that tiles up will just join up. With that construct in mind, my thingy here becomes from him 1, 2, 3 to him. So there's our direct insertion from red to blue. And let's put these on the same lines. Like that. I like the way that looks. Okay, so now we have to get this guy set up. And this means we have that. Oh, we're not going to have space for that. So that's what that's in the way of. That's fine. I like symmetry. So the upper edge of the power line is where the next machines are. And that is entirely acceptable. Except that this guy, yeah, so this needs to, I need to sneak 2 of them through from here. Which means this is wrong. This needs to go up 1, which means these need to go up 1, which means that the direct insert for the left hand stuff, these do need to be here. Like that. Oops. Like that. And I'm cheating a little bit. I already know that this is going to be coming across here and getting merged in. There. So a little bit weird at the bottom. This is kind of forced by the fact that I want to merge these 2 together and send them off. Up like that. And plastic is going to come down here and proceed onward to the next one. So it's fine. Just like that. Like that. So we drop inserters in for copper inputs and that input. Actually, let's keep this symmetric. So those are the same. So copper comes in here, feeds this guy. Copper coils feed these guys. Iron comes in here and feeds them, so we should be good there. We've got green chips coming in from the right. We have sulfuric acid here, and we've got red chips coming in this direction. We have a combination of coils and green chips merged here and sent up. So there we have it. Let's run a quick test of this. Let's see, matter sources. I'm just going to do this. If worst comes to worst, I can pick it up and put it down to clear things. This is copper. Heck, like I said, when worst comes to worst, I can always clear things out properly. So this right here has some iron on it. So this should be eating, what was it, 0.9 of a belt of copper? Yeah. And 0.7 of a belt of iron. Oh, and I'm going to need to delete the outputs. I haven't put the outputs up yet. So with these guys, I am going to mix and match here. Actually, let's just like that. Oh, that would have been unfortunate. I am out of undergrounds. So I can't test this until I go back and get more undergrounds. Can I make some? I cannot make some because I cannot handcraft those undergrounds. Me. Clearly 150 undergrounds isn't enough. Or I didn't refill before I started today. Okay. But I think if I get all this set up, fluid source, sulfur comes in, processors come out, and yeah, let's okay, so not having the undergrounds makes it hard, and I may have gotten some blue chips onto this line, which would have been confusing at best. So let's go get more undergrounds and come back with some stuff to build. Well, how far away is my... he's close. As you'll notice in the lower left, I'm absolutely counting on the representations I've seen from AMD that this CPU is intended to run at 90C. Now, while I've been playing, our junction temperature has hit 90. Okay, I think we're good. Does he have a bunch of extra stuff on him? He's doing okay. Let's clear things out. Yeah. So logistics off. Toss those in there. Pull things out of his trunk. There we go. Now we can turn his logistics back on and turn my logistics back on. So while we're doing this, notice we're still letting our base run normally. And right now, Creative Mod is using up about half a millisecond on each frame. Here we are. All done. Now we need to put these in. And, and now this should crank up and should hit our 181, 182 kind of rates. So the best smoothing I can get is by putting it all the way out to the right when we do 1 hour. Now this is, that's twice as many processing units as I expected. Do I have 2 of these put somewhere down somewhere? Because this shouldn't be... Max rate calculator says this is capable of doing 184.8 units per minute. Except it's going to be slowed down a little bit by not having enough copper cable, except that that's because we need extras of those. So where am I building blue chips in this base? How am I going to benchmark it? How am I going to benchmark it if I can't see what I've got? I'm not doing I'm not doing on-site blue chips anywhere. Oh, here. Yeah, my other base is building blue chips because I just picked up a bunch of things. And this is actually a fairly large blue chip array. So I'm going to have to wait for him to stop before I can get an honest appraisal of this design. So let's let this saturate. I will go ahead and put these in. Okay, those don't do what I thought they did. However, I can do it the other way around. There. So now potentially each one of these machines can output on either the near side with a mini loader or the far side with an express, with a stack inserter. Who would have thought that my other base would have been a significant factor? So we just wait for a moment for it to back up. I didn't trigger a lot of building there. The reason why I'm worried about this is that this is just on the hairy edge of being exactly what I'm designing for, and I wanted to make sure I'm actually getting 182 before I start dropping it down all over the place and mirroring it and so on. Oh, and yeah, I realized that the add-on that made it so you could mirror the blueprints was so useful. They put it into the game, so I can pick that up and I can say F to flip, and there is the whole thing right there. Now some things don't flip. I think anything with rail signals or rail signals or chemical labs or pump jacks, rail stations, anything like that that's not sufficiently symmetric won't work. And I think they made it so it just simply refused to do it. That's still going. I'm going to put this on pause and let that saturate the builder base. Okay, so we're back and it has stopped building them. So now I can go back and actually measure this, test to make sure we have the throughput we want. That ramps up as we clear the output area, and it should hit 182 or better. Well, it looks like it's in the right range. So that's sitting at 182 to 189. This is good. I will accept that. Even that brief test was enough to show me that we're working. So now we need to blueprint this for posterity. See how far down is that? A gap of 2 below him. That should line up there. I don't want to run this down too far. That should be good. These are all just below the top edge of the power, and this is all clean. There we go. So I should be able to grab this. I'm going to go ahead and pick up the stuff on the left. For some reason also, earlier I was... Oh, I know what's going on here. Yeah. Let's make sure that these... Yep, those are turned off. Good. I was having problems with the test stuff, the creative mode matter sources not being populated properly when I did this. Yep, and it's happened again. Oh, unless it's because I don't have any. Okay, apparently that is still true. So I need to put these down by hand. And copy into them with shift with the there. So here, I got a little bit of extra stuff in my blueprint, which kept the plastic from lining up. And that trims it back. And we can benchmark this. This should be half of my needed stuff. So we are expecting to see half of the required amount, which is 1086, so 543 is our target now. Oh, that's handily over target. Good. Now this is in the wrong place for me, so I'm going to pick up the whole thing and move it all over and then mirror it. This also means I'm going to get a whole bunch of copper and iron and such in my inventory. Let's make sure those are marked for destruction. Go. So we're going to save all of this as a blueprint. And pick the whole thing up. I'm going to be counting on also using this guy. So let's just walk out into the middle here. Does he have logistics bots? He has some logistics bots. Good. I think I'm going to put some stuff in chests that I'm not going to need for this build. Boom. Oops. I may need those. There. Now this whole thing, I wonder if that gets me okay, so picking up a bunch of stuff. Notice we got some excess here. Okay, I am going to set automatic deletion of things that are in trash slots, just so I can get this picked up. There. Anything else on him I want on me? That looks good. Green chips, I want 0 of them. And red chips, I want 0 of them. Okay. And now we put this down. So the... Oh, there's going to be a station at the bottom of this. Let's align on power. And I think this is roughly halfway vertical. Yeah. And then we hit F to flip and put down the other half. I'm not sure if there's anything else I can put down. Okay, so in this area, oh, that's interesting. Let's walk over this slowly once more. That's just kind of the normal stuff that I pick up. So we're just going to go get a normal load of stuff. how are we doing here? We don't actually need this blueprint anymore. I think we've picked up everything. There's some things in here that he doesn't need. Oh, I guess he's requesting those for a reason. So I don't need them. Okay, now back to... I think this will finish placing processors. Add tag, as is processing unit. You can see this is one of our, not one of, this is our most complicated build so far in this base. But what this does is it will reduce the amount of green chips and red chips that will be getting moved around by the trains. And I guess this wasn't quite enough. It was not quite enough beacons. Make sure everything else is filled in. Yeah, just beacons. Okay, top up everything and head back. Now while that's running back, I can actually just kind of watch the trains move. So we don't have a whole lot of traffic yet because we are not sending trains out for things we haven't built. So the only train traffic that occurs is when we're moving these four things, well, these three, LDSs, RCUs, and frames. We're about to add in processing units. Is everything filled in? Everything is filled in. So what we haven't done here, well, we want to test that we've got the right stuff, which means establishing all of these again. Okay. Stare at this for a bit. Everything should be basically green with the occasional little bit of orange where machines are underutilized. We should not be back. Oh, right. The void guys are not really void guys. So we're going to start out from saturated. And look at how fast that climbs back up when you start saturated. We are now at 1.1K, according to the graph. Now there is a line I found that prints it out for me. So 1058. So now we need the station. That much. Make sure the train stop name is off. I do not want to misdirect other people's trains. This train will be called if I just call it blue chips, we're going to start, well, the trains that will come to us currently have infinite wagons on them. Okay, there we go. So this guy, if I take out these, then all the blue chips will be on the left. Ditto here. If I take these out, they'll all be on the right. And our total throughput is so much less than a full belt that I am absolutely certain this is not going to have any bad effects. And there we go, splitting it up into our 4 cars. And of course, these stack to 200. And it's going to be 8,000. So 8,000 in a train. So the train's going to be very rare, which means that once we get this cranked up, if I need to make more for a train, if I get multiple trains at once, they're going to be crazy. So I'm going to start constraining this to half a row. And I'm going to set up the trains so they only get 1 row per wagon, unless they really, really need more. So now we need to grab these guys and start bringing them up here. Well, there's 2 stops. I'm fairly certain that these will come to this stop. Let's just do these one at a time. They don't, because I didn't finish laying the track. So I do have a lot of wagons. And that's the wagon pattern that I want to use. So he's almost full. Let's pick a different one. These guys, oh, right. These guys are going to be full because they have the fancies on them. Here we come. Yeah, it's going to take me a while. I'm going to do this off camera because I have to just refit each one of those trains and get them full of blue